All right, this video is to go over the operation of the first demo circuit for lab 1. Okay, so in lab 1, I'm going to use these first 4 switch positions to put numbers into this simple design. Okay, so if I put this switch up, you see that LED light up. That indicates 0, 0, 0, 1. Okay, and then the next thing I have is various functions that are tied to the buttons on the board. Okay, so the very first button, the top button, shows the decimal equivalent, the hexadecimal equivalent of the switch position. Okay, so if I press this button, you see 1 shows up in the display. Okay, if I flip this up where I have 0011, 0011 in binary is 3 in hex. Okay, so I press this button up, I get 3. Okay, the other functions have to do with add 1, add 2, or 2's complement. So this button takes the 2's complement of 3. This button adds 1 to 3, so I should get 4. And this button, this left button, adds 2, so 3 plus 2 is 5. All right, so let's do another combination. Okay, so this is 0, 1, 0, 0. 0, 1, 0, 0 is 4. If I press this top button, that verifies the 4. All right, this is the 2's complement of 4. We'll talk about that more when we get to it in the class. All right, but for now, just know that it turns out to be C. All right, and then the bottom button adds 1, so 4 plus 1 is 5. The left button adds 2 to get 6. Okay, so you might be wondering what happens when you have something like all the buttons, all the switches up. All right, so this would be 15 in decimal, all right, which is the F character in hex. We'll talk about that in the class if we haven't covered hex yet when you watch this video. All right, so if the top button, when I have all 1s, that shows an F. If I take the 2's complement of F, that turns out to be 1. You flip all the bits and add 1. That's how you do a 2's complement. So flipping all the bits gave me back down to 0. Then I add 1, I get 1 back. Okay, and then what's going to happen here is when I do F, 15 plus 1, that goes to 16. And this is only a 4-bit result. So 16 takes a 1 in the 5th bit position. So everything kind of rolls over and I get 0 showing up. So 15 plus 1 takes me to 16 and only the bottom 4 digits show up, so that'd be a 0. Okay, if I add 2, you could predict that you would get 1 showing up here because 15 plus 2 is 17. Okay, and so 17, if you represent that, the lower 4 bits are a 1. Okay. So that shows you the operation of how this circuit should work. And so what we're going to do in the lab is we're going to take some time and look at how this is put together in Verilog and get you started on the journey of learning how to implement designs in Verilog and use a workflow of EDA Playground and Vivado to make all this happen.